guys, Miss J here. You know, I saw the coolest movie over the weekend. This March of the Penguins. Maybe you've seen it, maybe you haven't. But here's what I thought was really cool. The penguins, daddy penguins, are the ones that take care of their little baby eggs. And the mama penguins, they go off and they get to go swim and they get to have all kinds of fun. And they spend the winter in the ocean and they get to feed, while the daddy penguins have to stay back with the eggs on their feet. Now, they're in Antarctica. They have the harshest winters of any place on Earth. And they don't have houses. So how do these daddy penguins stay alive and take care of their eggs? So cool. They all huddle together, tightly packed. And when they are tightly packed, they just wobble back and forth. Just that much energy keeps those daddy penguins alive, and it keeps just enough warmth that the whole group of penguins stay warm in these very harsh, cold winters. And they do that for about 3 months, and then the mama penguins come back, and they take the eggs and the babies, and the daddy penguins get to go into the ocean, and they get to finally eat. So as I'm watching this movie, it got me thinking about solids. See, solids and daddy penguins are very similar. Let's find out why. First of all, let's talk about what is a solid. And before we can do that, we really need to go back into looking at the object and not at the baseball, but the particles that make up the baseball. They're atoms, but we refer to them as particles. Now, in a solid, these particles have a particular way that they are lined up. They're nice and tightly packed, just like this image right here. Solid particles are lined up like little soldiers or daddy penguins. If you look at the March of the Penguins, or if you look at a picture of penguins that are sitting and holding onto the eggs during the winter, you will see that they are lined up. They're either in a nice concentric circle, or they're very tightly packed and lined like little soldiers. They do that because that keeps the heat in the best way. They vibrate back and forth in place. So even though they're very cold, they don't just stand there. They actually vibrate back and forth in place. And they have very little energy. Remember, the daddy penguins don't get to eat for 3 whole months. So that fish that they ate has to last them until they get to go eat again, which means they have to conserve their energy. Now, how does this relate to solids? Let's take this baseball. Inside this baseball are billions and billions of teeny tiny little particles. Kind of like the daddy penguins, they are lined up in nice little rows. And they are very tightly packed. And even though I cannot feel it, those particles are vibrating back and forth. Can't see it, can't feel it, but they are there and they are vibrating back and forth, just like the daddy penguins. Now, what does that mean for a solid? It means that solids have a very definite shape. This baseball is not going to change its shape. It will hold its own shape unless I do something to it, like smash it. And it has a definite size. It takes up an amount of space, and it will not take up a different amount of space unless I do something to it, change it. So the fact that those particles are tightly lined up and they're wobbling back and forth allow a solid to hold its size and hold its shape. And that is how the daddy penguins are like solids.